Hello, Math Studies students, and welcome to your online lesson. Today we'll be continuing our discussion of graphing quadratics. Specifically, we will be talking about identifying maximums and minimums of a quadratic, and we'll also be using technology to identify characteristics of our graphs. We will know we are successful when we can efficiently interpret and graph quadratic functions. A quick reminder that a quadratic function is generally written in the following form, where we have an x squared term. We also can have an x term and we can have a constant term. When it's an equation, we will set it equal to something. Generally, we will set it equal to 0 when it's in standard form. When we have a function, we replace the 0 with a y or with an f of x, and that allows us to actually graph this function. The most important part, as always, is having an x squared for it to be classified as an actual quadratic. Reminder from our last video, we looked at the graph of a quadratic and we saw that it was a parabola, which is this sort of U-V hybrid shape. It has a vertex, which is the place where our graph changes directions, where it goes from going down to going up, or vice versa. We looked at a formula that allowed us to find our equation of our axis of symmetry, also allowed us to find the x-coordinate of this vertex. And today we're going to sort of expand on some of those attributes of a parabola and look at some other ways to find that information. So the first thing, as we mentioned in our learning intention, is we want to talk about what a maximum or a minimum is. Now, a maximum can also be referred to as an absolute maximum, meaning nothing more maximum than that. And that is a spot on the graph where the output, which is often our y value, we input the x, we output the y. The answer is the y, that has the highest value. So the highest y value, the highest we can ever get to. And a minimum is the lowest y value, or the lowest output that we can possibly have. And those tie very well into the real world meanings of what a maximum or a minimum. Maximum profits, making the most amount or minimum amount of time to do something, the least amount of time it takes us to finish a project. So if I look at a graph where I have, let's take a parabola, but I want to flip it upside down so it looks more like this. That has a highest spot. The highest spot on it is going to be right here, which would be its maximum, its absolute maximum. Nothing ever goes higher than that. It does go lower, much lower. The arrows indicate that this graph can continue on and on going down, but nothing would be higher. And you'll notice that that spot is also the spot where it switches directions, known as the vertex. A minimum would be more like a typical parabola, like this. And we would see that we have a lowest spot, again, occurring at that vertex. And there's no spot that can be lower. Again, it goes higher, but there's no spot lower. Now, a relative maximum and a relative minimum, those are the highest or lowest spots on a graph compared to everything in its vicinity. Vicinity means in the general location or nearby or relative space. So I could draw a graph like this. And I would have a relative maximum occurring. And that relative maximum is going to be right at the top of this peak here. Now, of course, this is not a quadratic that I just drew, but it has attributes of it where it's got this vertex happening here, and that's its highest spot. But eventually, it does come back up even higher, and there's points over here that are even higher. But for a while, this spot here was as high as it could be. If I went immediately to the right or immediately to the left, in both cases, I was heading down. So this was the highest spot. That would be a relative maximum because there was no value higher than it in the nearby vicinity or close to it. But we could also have a relative minimum, and a relative minimum would be the relative lowest spot, like right here, where there is nothing lower than it immediately to the right or the left. Now, eventually, the graph does continue down. The arrow indicates that, and we would have points on this graph that are lower, but not immediately near it. So those are relative maximums and minimums. Now, those won't factor into a quadratic because a quadratic will essentially only have a highest and lowest spot since there's just a single vertex on there. But since we're introducing this vocabulary, we may as well talk about all the different applications of it. So if we're given a quadratic function in that typical form that we see on most of these lessons with the ax squared, the bx, and then the constant being added on. And again, we don't even have to have the b or the c, but just based on the a, if the a is greater than 0, that means that our parabola will be opening upward. It's extending up The arrows are going up, and that would be like, something that would hold water if you think of this as a vase or something along those lines. Now, what does it mean for a to be greater than 0? Well, let's think of values that are bigger than 0. 1, 2, 15, a billion. All these numbers are bigger than 0, even 0.5 or 0.1 or 0.007. They're all bigger than 0 because they are all positive. And that's what we need to focus on here. Positive a values mean that our graph is going to open upward. If our a is less than 0, then we are going to have our graph opening downward. And again, what does it mean to be less than 0? It must be negative. So any negative a value, meaning there's a minus sign somewhere or a negative sign somewhere in front of our x squared, that means that our graph is going to open downward. Now, let's refer back to our last slide where we talked about maximums and minimums. If it's opening upward, is there a highest spot on the graph? And the answer is no, because it's extending upward forever. So there's never a highest spot. I can always go higher. But is there an absolute minimum or a minimum value? There is, and it would occur right at the vertex. It's the lowest spot. You can think of even like if I rolled a little marble or something down, where would it end? It would end up right here at the bottom because that would be its absolute lowest spot. However, if we look at one that has a negative a value, that opens downward, and it does not have a lowest value because it's going to keep going down and down forever. But there is a peak or a highest spot on here, and that would be our maximum or our absolute maximum. And again, it's the vertex. It's just that now it's a maximum because the graph is facing downward or opening downward. So those are some things we can keep in mind here as we look for maximums and minimums. The way the graph opens will help us to determine if it's a max or a min. So for our first example, we're going to find the vertex of the following function. It's a quadratic I can see already because it has the x squared. And we're going to state whether it's a maximum or a minimum. So we're going to find the vertex and decide if it's a max or a minimum. We're also going to write the equation of the axis of symmetry. And another one of the things I mentioned that we were going to do on our learning intention is that we're going to introduce some technology to help us out. So we'll look at that in just a moment. But first and foremost, I could use my equation, which is x is equal to negative b all over 2a, and I could find my axis of symmetry, and I could also find my x value of my vertex. But before I do that, I'm going to answer the question of, is this a minimum or a maximum? And to do that, I'm going to simply look at the a term that's happening right here. What is in front of my x squared? And there's an implied 1. There is a positive 1 x squared. And so that means that my graph will have to be facing this way, opening upward. So the question is, are we going to have a minimum or a maximum? And I can tell you already, we are going to have a minimum. Again, how do I know that? I know that because my a value is positive. And if I have a positive a value, my graph is opening upward. And if it opens upwards, that means there is no highest point because it will extend on forever, up and up and up in both directions. But there is a very lowest point. It will be the vertex. So now all we have to do is find that vertex and also find the equation of the axis of symmetry. And to do that, we're going to use some technology. So I've pulled out my calculator here. And the first thing I'm going to do is I'm going to get that equation into my calculator. I go to my y equals, just like we did when we were solving quadratics or when we were graphing them. And I start off with my x value. I'm squaring it, minus 4x plus 1. Hit my graph key. And I can see that I have a parabola. It is opening upward, just as I expected. It does have a minimum value. And I just want to know what that vertex is that we can see happening right around there. So I am going to let the calculator tell me where that vertex is. Now, as I press second trace, which is often the button we press when we want the calculator to solve something for us or to get us a value specifically, we press the second trace or the calculate button. And you'll notice vertex is not one of the options. We've used the intersects right here, the choice 5, when we were doing systems of equations. We've used the 0 to solve quadratics, but there's nothing here that says vertex. But what it does say is we have minimum and we have maximum. And that is really helpful because we already know we have a minimum on this graph. So that's the one I'm going to select. So I have to think about this before I go to allow the calculator to help me do this. But since I already decided I have a minimum because my a value is positive, I'm going to select choice 3. Now it asks me left bound. That reminds me a lot of when we were solving quadratics. But this time I'm not going to go to the left of one of the x-intercepts like here and here. I'm going to go to the left of my minimum, also known as my vertex in this case. So I'm going to move my cursor so I'm just a little bit to the left of the vertex, and that's where I am right here, and I'm going to hit enter. Now I'm going to go a little bit to the right of that vertex, and again I'm going to hit enter. So I had a spot here, a spot there, and you can see that the calculator has actually indicated the small region vertically that it's going to look at. So it's going to look at everything in between those two little arrows and say, what is the lowest spot in that region? And since I know my vertex is in that region, it will actually give me my vertex value. Guess doesn't matter because we did such a good job of like telling the calculator where to look. So I'm just going to hit enter for that. And I end up with my vertex value of 2, -3. So that is our vertex. We also know that it is a minimum. And lastly, we also know the equation of our axis of symmetry because the axis of symmetry is a vertical line that goes through our vertex. And a vertical line has only x values. Like every y value is fine, but like the x value that I know every x value is going to be 2. The y can change, but no matter where I am, whether I'm here, or down here, or down here, every one of those things is going to be 2 over. So for a vertical line, we always write x equals, and again, it's going through x equals 2. So these would be my 3 answers. Once again, I have my vertex here. I have identified that it's a minimum, and also I know that the equation of my axis of symmetry is x equals 2. All right, let's do one more of those. So for this one, again, let me move the calculator just a little bit out of the way. I want to find the vertex of the following function and state whether it's a minimum or maximum. Also write the equation of the axis of symmetry. So basically the exact same thing that we were just doing over there. Now, do we have a quadratic? Absolutely. We know that because there is an x squared happening. However, the a term this time is a -2. Now, I'm not going to be too concerned about that -2 other than I just know which direction my graph is going. Since it's negative, it means it's going to open downward. And because of that, will this graph have a minimum or will it have a maximum? And I can clearly see it is going to have a maximum. And that maximum value is where my vertex is going to be. So I can already answer part of the question. I have a maximum value. And I'm about to find the vertex. Again, we'll use our calculator to help out with that. So I go to my y equals. I'm going to clear out my old function. I have -2x squared minus 3x minus 8. I'm going to graph it. And you will notice that this doesn't even cross the x-axis, so there wouldn't be no solutions to this. But it does still have a vertex. It does still have an axis of symmetry. The problem is I can't see it very well. It's all happening right down here, and I wish I could just see it a little bit more clearly. So what we could do is we could zoom in a little bit, and I think I'm going to go ahead and do that. So I'm going to press second accidentally, but I'm going to go straight to zoom, and I want to zoom in. Now, there's a tiny little cursor that shows up right here at the origin, and it's just lightly flashing. It might not even be showing up on this video, but I just need to move my cursor down so that it's closer to my vertex. If you ever lose it, you can always look at where the x value is and the y value is to have a better idea of where it's at. And we're a little bit at like a -0.6 and a -6 for my y, which means I'm down 6, but over just a little bit past a half to the left. And so now I'm going to hit enter to actually zoom in. And now I have a little bit better idea of what's going on as far as where my vertex is. Now I'm going to press second trace. We said that this one's not a minimum, but rather a maximum. So I'm going to use maximum to find it. I'm going to go a little bit to the left of my vertex. Again, my vertex is that highest point right there. So a little bit to the left, I hit enter. Now I go arrow over to find my right bound, a little bit to the right of the thing I'm looking for, which is the vertex. Again, as you can see, the calculator has put these two little arrows to say it's going to look here in that region and say what the highest value is, what the highest y value is. So I'm just going to hit enter for my guess, and we can see that we have a maximum occurring at -0.750011. Or if we round that to 3 significant figures, we're essentially at -0.750. And really, I'm fairly confident that it's just -0.75. 5, but I will put the 0 on just so that I'm doing my correct rounding rules there. So that's my x value. Now that's the x value of where the minimum is occurring, but the actual, or the maximum, I'm sorry, but the actual highest value is the y value. And the highest this graph ever gets to is a negative value, and the highest that is negative 6.875. I'm not going to round that one because it's exact. It doesn't continue on, and I may as well leave it exact rather than going through an extra step to round it. So those would be the coordinates of my vertex, which we already identified as a maximum. Last thing I'm going to do is write my equation of my axis of symmetry. Remember, that goes right through my vertex, and an equation that's a vertical line always starts with x equals, and it's going to be x equals negative 0.750. And that would be the equation of my axis of symmetry. All right, so throughout today's lesson, we looked at using some technology to help find some of the things from our previous lesson, including axis of symmetry, as well as vertex, and then we defined what maximums and minimums are. Till next time.